Test, 1, 2, 3, test. Test, bon matin. Ceci est MontréHack. faire le petit test de son.
Ouais, test, test, test.
Tu peux commencer quand tu es prêt dans ce cas-là.
Ouais.
Quoi? C'est Julien en forme de précision.
Ah ouais, donc il y a vraiment un gros délai. Bon, c'est pas grave. Ok, bon, il y en a qui arrivent bientôt, mais je pense qu'ils pourront rattraper. All right, so we are going to start. So today I'm going to show you a CTF track I've made for an internal CTF at my work. So Desgazons is related to nothing, of course. But yeah, so it was a nice track, and I thought it was a good idea to display this for people. There are a few things that are quite interesting to learn. If I can, yes. So this is the table of content. So get on track, basically I will give you what you need to have to get on the CTFD, set up your account, and then start hacking the track. It's a 6 flags track. Pwn. So yeah, it will be the time for you to try to get some flags. We will have, we'll take a moment in the middle of the presentation I will make a sort of masterclass on Git and dangling commits, if some of you heard of that. And then after that, it will be kind of the end of the track where you get a remote command execution on the server. And after that, you get a final previsk, and then it's done. So basically, it's not that much complicated. I will give you guys some time between each steps to try to see what you can do for yourself. I will, of course, show how to do it with some few hints along the way so that you can try to do it on your side before getting the full answer. And yeah, that's basically it. So normally, if everything works, you can get on ctfd.desgazons.firefox.cc, and you will get a CTFD. And you can register with a new account using the code Desgazons. And then you will have the CTF track Desgazons 1, which is the beginning of the track. Basically, it's a really easy flag just to make sure everything works for you and that the challenge platform is working. So I will give like 5 minutes just so that you can create your account and submit the first flag, which is very, very easy. And yeah, for sure, you will encounter someone during this track that is named Timmy. So beware of Timmy. He's kind of the guy you don't want to have on your team. You will have few comments related to him. So when Timmy is commenting the code, maybe you should take a quick look at this code. Maybe it's the vulnerability. So yeah, I will leave you guys just register your account. And if you have any issues, you can just ask. And for people that are remote, I'm also available on Discord, so I will see messages. I'm on the MontréHack Discord, so yeah, you can just message me. All right, so I saw that many people already had the first flag, so just to get everyone on the same point, basically you can create your account. Sure. Right, so when you are on the first flag, you can just go on the URL and you get a super website. And inside the HTML source code, you will get a forgotten link that was commented by someone, which is something that happens a lot of time in reality. You can get a lot of interesting informations in JavaScript or HTML, like API endpoints or other stuff. So this is just a really simple example, just so that people get a first flag to just feel happy about themselves. But the real flag will start, the real check starts on the internal Git instance of the company. So Git is like GitHub or GitLab, basically a website that provides Git server features. So if you go on Git, you get that nice website. And one thing that's interesting is that in real life, some companies expose their private instance of GitHub, GitLab, more GitLab. There's a lot of companies where if you do some Google Docs or maybe search on the Census or other stuff like that, you will find some private instances of GitLab. And sometimes you can get some public accessible repositories on those instances that can contain private data or maybe interesting stuff for you. So in that case, you can simply click on Explore, and you have some available repositories you can visit. And then you can find something interesting in one of these repositories. So I will let a few minutes for you guys to explore and get what's the interesting thing. But basically, the goal is to become authenticated on the platform. So somewhere you will find some credentials for an account, and then you can continue the track. So we'll leave you a few minutes for you to do that. Okay. All right. So I saw that some people solve this flag, but I will still go because we have other stuff to talk about. So basically, on the website, as I said earlier, you have some repositories, some new repositories. So if you go on some website, you will find this magnificent website, which is pretty ugly, but of course it's just to add some lore on the track, but it's pretty much useless. If you check, there is only one commit, no branch. So at first sight, it might not be your focus. But if you look at the other new repository, it's named personal. And so it's Timmy's personal repository. You can find some quite interesting stuff, like his curriculum vitae, which contains bullshit stuff. And if you look at the commits, you see there's some stuff happening, like fuck fixed, etc. So maybe something weird happened. And if you look at his to-do list, of course it's in French. So sorry for people not speaking French. I should have thought of that earlier. But basically, of course, in real life, you will just use Google Translate like a normal human. But yeah, here you can see that there is one thing that's done is delete the commit that contains my passwords. So maybe it's the classic case of, oh shit, I pushed something I should not put on my repository. So maybe my passwords or my SSH key or other stuff like that. It happens a lot of times. So like maybe you're a dev working on a project and you have your personal files that you use for your development, local development. And then all of a sudden you git add everything on the repository and you push everything to GitHub. And then everybody has access to your GitHub personal access token. So you don't want to do that. So then maybe Timmy saw that that's what he did. And so he tried to erase this information. And if you look at the commits, you won't get any interesting output. You can do the same technique as before, like cloning the repository locally and try to inspect a bit more the content of it. Of course I can't, I have to authenticate. And so if you go inside personal, you can get basically all the logs at once with this command. And there is a lot of stuff, but basically nothing interesting. But there is something interesting, but it's not on the local repository. So when you git clone, you don't have it, but there is something interesting. And if you go explore the activity stuff, you have activity here. You click on it, you see a bunch of graph, but you don't get, you can't click to get more information. So on Gitty, it seems a bit useless here. But if you go on Timmy's personal page, you get something called public activity. And if you click on public activity, you find some commits, stuff that happened. And something that's quite weird is that you find some commits that seems to duplicate. So you have fuck and fuck here again, but they don't have the same hash. So basically Git hash everything so that it gets a unique ID to handle its stuff internally. We will go talk about this a bit later, but you get some duplicates commit. And if you click on this one, you get the commit here. So you have the hash of the commit. And if you open it on the repository, so you can just do git log the commit hash dash p to get the output. And you get the same thing as before, just for this specific commit. But if you look at the other fix emoji that has a different hash, you will get, so the fix emoji stuff, and then a new file named passwords.txt, which contains a new flag and another account. And if you inspect the hash of this commit and you want to look at it inside the git clone stuff, Git is not happy because this commit does not exist locally. So we are in a situation where by git cloning the repository, you don't have everything that the server can offer you in the graphic, in the website or in the API. And this is a situation that is really interesting. So maybe some people will have git clone all of Microsoft repositories and will have launch git leaks, Truffalog, there is nothing. But then all of a sudden, someone just clicking on activity stuff will find something that you won't get by git cloning. And so what the hell is going on? So like, it's not a common behavior. And so we'll have to go in depth inside how Git is working. So yeah, I will just set up my PC to do that more easily for me, and I will continue in a few seconds. All right, so what is going on? We can do a bit of local stuff inside the new repository to understand what is going on. I'll just zoom a bit for you guys. So, nope. We will create a new directory. We go inside demo, so this is an empty folder. We just git init, so we have now an empty local git repository. We can echo hello in hello.txt. Using git status, it shows us that the file is not tracked, so we can add the file to git tracking, and then we can commit this new change. And so we have our first commit. So now if you do git log, Git will show you that we have this commit, first commit. Again, if you do this with -p, you will see the changes added by this commit. So the file hello.txt was created, and its content is hello. And then we can add another file that will mimic the behavior of someone leaking his secret stuff. So we will echo secret in secret.txt, and then we will add this file, commit it to the repository. And now if we do git log again, we'll see the new commit, which contains the secret that the dev maybe pushed. And so here, if we git push this on the server and git clone, we will have the same content. We will have two commits, which is perfectly normal. Like normally everyone here is okay with what's happening. But that maybe the guy is like, oh shit, I commit something I did not want to. And so I will try to erase him. So you have few methods to do that. Doing rebase stuff or force push if you do this on a remote repository. Like Git allows a few stuff to rewrite the history in a way that is not quite common, to fix stuff when you fuck up everything, or maybe just to arrange your history because you want to. And so here we could kind of erase the commit from the repository. One way to do that will be to change what master is pointing to. But what's master? Master is the default name for Git branches, like the first Git branch is named master generally. And it's like a kind of a domain for an IP. You don't have to learn the hash of every commit. You can just show me git log master. I want to see what's on master. And we'll have the same content. And so internally, Git has a file that says master is pointing to this commit, the last one. And I believe most people have saw in the past that there is a .git folder inside Git. So if you inspect it, you have a bunch of internal files that Git uses to manage the repository, the history of the repository. Like you have the config stuff. So like sometimes Git says to you, you have to choose a username and an email to for your commits. And you can do that globally, or you can also do that just simply for the repository. And so it will store this in the config file of the repository. And you have other stuff, a folder named refs. So it's references. So Git uses two types of references to handle stuff, and you should probably know both of them. It's branches, so master, etc., and tags. Tags are usually used for release stuff. So like you will have a tags named v1.0 for the first version of the project. And so tags tends to be static. So the commit behind the tags is not going to change, but branches are more dynamic. So if you add you're in the master branch, if you add a new commit, automatically master will point to the new commit. And so this is stored in the ref folder. So if we open it, we have heads and tags inside these folders. And if we look at heads, you have the master file. And then we can simply inspect what's inside of it. And we just simply have the commit of the hash of the commit. So when you add a new commit to the repository, Git will simply just change the content of this file. And then when you say, I want to check out what's inside master, it will just look at this file. Okay, this is the commit he wants, and just show you what's inside of it. And so one way to erase this commit would be to not reference it anymore. So it will be like a dangling commit, so that you can do stuff like git reset. So if we want to maybe just erase the last commit, we can take the hash of the first commit, and we would say git reset hard, and we give the hash of the commit. And then when you do that, head is now at the first commit. And if you look at the files, you don't have the secret.txt anymore. And since Git also tracks which branch you're currently using, so in this case, master, it will change master content. And so if we look again at what's inside master, now it's pointing to the first commit. So Git changes a bunch of stuff when you do that. And now if you do a git log, you don't have the secret.txt. If you do like all, you still don't have it. But the content still exists internally inside the Git. And so Git have few commands to do like internal plumbing to change stuff in a way that most users won't do. One thing it has is git fsck, which if you open the man is something to check the validity of objects in the database. So it's like ensure the integrity of everything. And with this command, you can ask him to give you the dangling stuff. So this command full, it asks you ask the Git to use every object, and no reflogs. I won't explain that because it will be not useful for you. But if we do this, now Git is like, man, you have a dangling commit. So basically a commit that is not referenced by anything. And if you take the hash of this dangling commits and you want to get the logs of it, you get back your secret.txt. So everything here is just locally. So, but you can have an idea on how someone would want to change its history and to prevent secret leak. And to add a bit more sense on how this will work in reality, we are going to do the same thing, but using GitHub, so that we will have a proper repository where you can git push stuff, git clone, etc. And I will show you the differences because here, even by rewriting the history, we'll still have access to the secret.txt. And so I will just do something. Okay. So we can create a new repository, which will be named demo. And it's just an empty repository, but so that GitHub have this repository and we can git push to it. So now we have this repository, and we can just take its instructions to create a new repository. So we will go somewhere and just paste the commands. And now we have git push something to GitHub. So normally, now you have the README and your first commit. And so if we do the same thing as before, we will create like the secret.txt, add it to the repository, create a commit for it. And now we can git push. And so normally we have a new commit inside GitHub, which contains the secret. And at this point, maybe the dev or anyone using GitHub actually might want to erase this information because we don't want people to get access to it. It's like a mistake. So we will say, okay, I'll have to change stuff. I will just change what master is pointing to and reference the commit and git push, and we will see what happens. So we can do again the git reset hard, and we will say, so like this is the commit before the last one. And so basically we just want to erase the last commit of the branch master. And so now we are pointing again at first commit. And if we do git log, we see that main is pointing at the first commit. But server side, the master is pointing as to a commit that is different from main. So stuff will happen and Git won't be happy. So if you want to git push this, the server reject what we just did because it's something that is not normal. Normally when you push, you add new commits. So the server will have, okay, I have new commits to add to master. So we'll simply register the new commits and then change what's master pointing to get the new content. But here you're asking GitHub to roll back and erase the commits, so it's not happy. You can see in the int and the yellow text that GitHub is saying the tip of your current branch is behind its remote counterpart. And so one thing you will have to do to overcome this is to git force push, which simply says to Git, just do what I ask. And so now, if we go back to the server, secret.txt doesn't exist anymore. And inside the repository, you only see one commit. So you're like, okay, that's cool. Nobody saw that I pushed my secret, so I'm happy. And maybe I can be a bit cautious and want to try by git cloning the repository and see what's inside of it. So if you go back to here, we git clone the repository. We have demo. We go inside of it. We git log everything. We just want to make sure we have no secrets. Okay, we just have the first commit. We are happy. Maybe we can do the same thing for git fsck to see if there is any dangling objects. But so far, so good. We don't have any secret locally. So anyone git cloning the repository is not won't have our secret. Of course, inside the other repository, which should be here, if we do git fsck, we will see that Git is telling us that there is a dangling commit. But it's like, okay, it's our own repository. It's our own computer. It's no big deal. But actually, if you explore the activity stuff on GitHub, like the same thing we did on Git to get the third flag, we can see some interesting stuff. So we can see the force push and the commit adding the secret. And so if we just open this commit, if he wants, we then have the secret file. So we are in the same case as on Git, where just by exploring the interface, we have access to data that is not inside your local Git repository. And once again, if we take the, I believe this is the hash of the commit adding secret. And if we go to the Git clone we did and want to get the content of it, now this is the first commit, so we will take this one. The commit is not existing. So you see how using activity stuff on GitHub, you can get access to those type of secrets. And actually, I've made a tool to automate everything so that you don't have to just try explore any stuff. So you can just go inside the newly Git clone project that does not contain the secret.txt, and you can launch this tool, and it will do a bunch of things. But pretty much it's fast because there is only so much on the repository. And now if we git log again, we have access to the secret.txt. So this is like something you could add to your, maybe you are monitoring public repositories or have access to internal exposed GitLab of a company, and you want to get more information that most people would have access to. You could git clone every repository they have and then launch this tool to just get all the commits that you won't get by git cloning them. So that's pretty interesting. So then when you will run truffle-log and gitleaks and stuff like that, it will be able to try to find stuff in commits that most people will not have scanned. So this can be useful. But this is where I want to go more inside of how Git is working, because how my tool is able to bridge what you see inside the GitHub interface and what's inside the Git repository, how you go from a page showing you stuff to a proper commit inside the repository. And so for that, you have to understand a bit more how Git is working internally. And so we've talked already about branches and tags. We know that branches and tags point to commits, so most people will know about this stuff, but less people will know about blobs and trees. So that's two other types that Git use to handle the history of a repository. And there is a lot of internal Git plumbing commands you can do to interact with those stuff. And for example, you have a git cat file. So if you open the man of git cat file, it's basically saying that provide content for repository objects. So it's more to do internal stuff. So for example, if we open the git log, we will get the hash of this commit. And using git cat file, we can really get the content behind the commit, so that what Git is storing. Git is not storing this nice output with colors, of course. It's storing like metadata about the commits, and we can get access to it. So using git cat file, -p is like pretty printing, and we give the hash of the commit. And now we have access to different stuff. So like we have the author, which is me. So the committer, which is also me in this case, signature because I just signing my commits, but it's not relevant. And I think the output is a bit messy. Yeah. And we have at the beginning a tree. So this is our new type of object. And you can, you also have the first commit, which is the name, the message of the commit. So this is what is really Git storing inside of it. And we can cat this file ourselves. Like if you go inside the .git, there is a folder that is named objects. And if we go ls what's inside objects, we have some folders. And basically, the folders with random letters are the first two letters of the hash of the object. So for our commit, which starts with 8 and E, it will be not here. This is unexpected. Maybe I don't know everything about Git. I know why. So this is something else, because basically Git is packing everything. When you git clone something, Git will like create a zip of every object, and it will be stored as is in your repository. So you have to manually say to Git, expand everything you have inside the pack files. So if you go into Git objects, we have pack, and we have two pack with .idx and .pack. Basically, the .pack is like the file that contains everything. A .idx is like how to read this file to get the offsets of every object. But if we go on our first repository that we've created ourselves locally, Git did not pack everything because he didn't have to. So I believe it's here. And then if you go to Git objects, then we have our expected folder, which starts with 8E. And so if we check what's inside 8E, we have the rest of the hash. So basically 8E blah, blah, blah is really what we have here when we do git log. And if you want to open what's inside this file, we will get something that it's not readable, because to be efficient, Git compress everything. So I think it's like zlib or something else. So we will have to unzip kind of the file to get the content, which is what Git is doing when you do git cat file. Basically, Git is doing that. So you could do that manually by opening the file and unzipping, but git cat file is just convenient. And so to continue on Git objects, we have the tree object. And we can also git cat file this object as well to understand what's inside of it. So basically, inside Git, when you have a big hash, you can just git cat file the hash to get access to it. And if we git cat file the tree object, we see the README, which is the same as what we have in the repository. We see some numbers here, which is the Linux permissions. So like Git knows what permissions to apply to the file when it will create it. We have the hash of this object, and here we have the type of the object. So this is a blob for our last Git objects. But a tree can also contain other tree. So basically, tree are like folders. And the main folder is like the tree that is inside the commit. So basically, if we ask Git open this commit, so like we want to Git checkout a commit, like master or any branch, Git will check the commit content. It will be, okay, so this is the main tree. It will open the tree, find every entries, find every subtrees and every blobs, and basically create the same structure on your file system, creating files and folders. And if we open the blob, so our last Git object, we can again use git cat file. Oops. Nope. Not. Okay. We have the content of the readme.md. And why does Git use blobs with big hashes? It's also to be efficient. And so that if two files have the same content, Git will not store both files. It will simply store one blob that references the same content. And when it sees inside the tree that the blobs x66 is here, it will take the content of the blob and create the file. So if we copy README to another file, and then we add the another file to the repository, we now have two files inside the repository. But if we open the commit behind this, we have the commit, the hash of the tree. And if we open the hash of the tree, we have access to the two files, another file and readme.md. And you can see that both entries reference to the same blob. So this is just how Git works. So it's pretty interesting just for your own culture. But basically, my tool, it's just recreating those objects locally by querying the GitHub API. It can get all the metadata that Git needs to create those objects. So the blobs behind each file, the trees, the commits, the date of committing, etc., etc. And just by querying automatically the activity API and then all the tree blobs commits API of GitHub, you can get all the metadata and create those files locally. And we can do that also ourselves manually. We can create a blob out of nowhere by using the command git hash object, which by default is to calculate the hash of something. So -t is to specify the type. So, and stdin to specify to take the content from stdin. And then Git will simply say to us, so this blob will have this hash. But we can also say to it, write this object to the repository. And so now we have this object that exists. And if we do git cat file of this object, Git knows about it. And then if you do again the git fsfk, now it sees that this blob is dangling. That's because it was created out of nowhere. So it's not normal for the repository. So for Git, it's like, what the fuck is going on? By inspecting what's inside master and what's inside every other commits that I know about, I don't find anywhere that this blobs is used. So it's simply a dangling stuff that should be deleted. And actually, normally, like when an object is like 2 weeks old, it will get automatically deleted by Git. So if we do a Git push, if I wait 2 weeks, which I won't do right now because it will be a long time, and I git push, normally Git will automatically garbage collect those dangling objects just to be efficient, because that's a situation that can happen a lot in normal stuff. So basically, if you create a branch where you want to develop a new feature for your product, and then you want to merge this branch inside main, but you want to stash commits just to get a nice history, so you can do stuff like that. All of your specific commits of your feature branch will be merged into one new commit, and this one new commit will be added to the main branch. And so after that, the other branch can be deleted. And so you have a bunch of commits that are not referenced by anything because the feature branch was deleted because you don't need it anymore. So just to say that this type of situation is like, it's not like normally, it can happen a lot. So it's pretty normal to have this. And that's why Git will automatically garbage collect stuff. And that all of these commands exist is because it's like a normal expected behavior inside the life of a repository. So the shameless plug is that I release my tool on my GitHub account. So you can just use it for yourself if you want. If you want to find it, I have a blog post with this that explains a bit more everything I've just said, but with screenshots and a less thick French accent. So if you type like dangling commits ethic, you will find the blog post, or just searching maybe dangling commits inside the GitHub search bar, you can find it. So yeah, that's pretty much the big part I wanted to talk to you about and how Git works, just to understand way more what happened inside the third flag. So it can be very quick to find the flag accidentally, but it takes a long time to explain why you found this flag. So yeah, now you have access to a new account, which is SVC Web with a big password. And take the password. If you sign in again with this account, you now have access to new repositories, actually one new, the admin repository, which contains some PHP file and service, which is here. So this is a service that requires authentication. Just so you don't waste time, you can use Timmy's credentials or the SVC Web credentials. It's like there is no vulnerabilities on this. And basically, to get to understand what you can exploit, you can just simply look at the code on the Git, which is the same code deployed on the admin panel. So like the last commit is like the content on admin panel. So I will use some time to try to explore the PHP file, understand how the services work, and maybe how to exploit it. Basically, you want to achieve a remote command execution on the server, exploiting this admin panel. So I will leave you some time, like 20, 30 minutes to get a big foothold on how this service works. Parfait. Qu'est-ce qu'on voit? On voit pas image. Ok. All right, so I'm going to give you guys a bit of a context of what you have to do. This is not an easy remote command execution to exploit, so it will take few hours for most good people to just try to do stuff. So the goal is obviously not to make you guys wait too much to try to understand, especially for people that don't really know how to approach this. So the goal here is to give you some context on how you would approach those type of scenario and to get a glimpse of what you have to do to exploit the vulnerability. And then I will give you some times to really try to exploit by having all the tools, the knowledge you have to know to exploit this. So in real life, when you do bug bounty, you won't get most of the time source code of applications you're attacking, or maybe if it's open source, you will have access to, but most of the time it's not. And it's the same also in consulting. Sometimes when you have an engagement, you don't have access to the company is not really, doesn't want to share you its code base, but sometimes it also happens. And if you are working for a company as like your internal pen testing, then you have most of the time access to the code base. So it's like white box scenario versus black box scenario. Here we are in a white box scenario by hacking the code base, kind of. So it's convenient for us. So obviously you will have to inspect the source code to exploit this advantage. Because this is the type of vulnerability you cannot exploit without having the source code. There is simply too many hidden things you have to understand of the application to really understand how you can make states that can be exploitable. So obviously, you will want to download the repository. So I have to open it. Up. So the admin repository, can be downloaded just by using a git clone. Admin.git, but of course it will ask for credentials. So now you have access to the source code on your computer, and it's just more convenient to use your favorite IDE to understand how the application is working. So we have a bunch of PHP files, footer, header, index, login, logout, logs. So not that much of a code base. And you also want to understand how the application is working normally. So sometimes you will want to deep dive directly to vulnerabilities, trying to exploit XSS or just putting single quotes everywhere to just get some low-hanging fruits. But a nice approach when you have the time is just to use the application normally, try to click on different buttons and stuff, and have everything logged in your burp suite, for example, so that you can just understand how the application is supposed to work, like how normal people uses the applications, because what you will want to do is to get out of the normal behavior, but for that you have to understand the normal behavior. And especially for business logic vulnerabilities, you have to really understand what's the purpose of the application, because just popping XSS everywhere is not going to help you discover those types of vulnerabilities. So by going on the admin, we are redirected to login.php. So we can inspect the code. We have PHP sessions. Maybe I will change to get a better output for you, because this is not readable. I don't know how to do that, but I will try. And I don't know how to change the color in VS Code. I just want to remove the black themes. I don't know. Dark, okay, maybe if I do light. Yeah, okay. Yeah, so it's much better like this. All right, so we have the login.php that's check if you're authenticated, and if that, it redirects you to index.php. And there is also the post request when you send credentials. So it will check that you have the username and the password, and that you are doing a post request. And if everything is good, then you get to this code where it checks that your username is made of, I guess, letters and numbers, and that the password is not above 25 characters, which is something common in applications to have like limits on values you send to it. For example, some systems don't support passwords that are above a certain length. So the front end will stop you to use those passwords. And then when you send your credentials, it will simply do the classic stuff of checking if your password is correct. And if yes, then you are redirected to index.php. So we can check on it by authenticating with Timmy's credentials. So we log in, and then we are redirected to index.php, where we have other stuff. So yeah, everything is working as expected. And then we have a else. So basically, if the authentication is not successful, then you are inside this code. And then we have Timmy. So probably the thing that is going to be exploitable. So there is logs files that are created based on a token. We will see that later. And it saves the username and the password you are sending to the application. So basically, when you're doing a wrong authentication, it will just save what just happened. which can be useful to detect brute force attack or any other stuff. It's very common for applications to do logs. And you will get 401. So if I open another page and I do this, I have a 401. So yeah, this is just the authentication part. So if we inspect other files, footer and headers simply contain static stuff. So this is the kind of stuff you just want to ignore, like it won't change anything for you. You have a logout.php, which simply destroy your session. So not many things interesting to look at here. And we have logs.php, which here is kind of a helper for you to exploit the remote command execution. So we'll go back on this later. And so the last part is index.php. So this is really the good stuff you want to look at, which is the main feature of the application. You can test services. So the first thing you want to do is click on it, and then click multiple times. Just do random stuff. You just look at what's happening. If you have your burp on the side, you can see all your requests. Of course, it's not going to be readable like that. So I have to change the theme. Increase that. Seems a bit better. So you have all the requests, and you have the post request. I don't think it's very readable. I will increase again the size. Wow, okay. That was a bit too much. Okay, it's just not moving the size of this text, so it's a bit annoying, but yeah, you just have the request you're doing. So just a nice way to approach this is to do many things and then inspect what happened inside your browser, just to get a glimpse of what's happening. Like that, you can sometimes understand that there is a H/API that is really used intensely whenever you are doing something. So you can understand what's the structure of the application, and then maybe you can brute force like web URL doing like GoBuster, FUF. Many tools exist to brute force URL on the web servers. So it's a nice way to understand what maybe subdirectories can be interesting to brute force. So you're not going to just execute the tool randomly on the web server, but you can try to use the tool to brute force specific subpath of the API or anything like that. But here, because you have access to the source code, this is the type of things you don't need to do. So you can just concentrate on specific vulnerabilities. And so the test service is really going to be the way to trigger the remote command execution. If we look at the code, we have the token stuff, and Timmy talking about it. So you have to keep that in mind. And you see that the website output the token. So you have access to your token here. And if you read a bit the code, you understand that the token is linked to your PHP session ID. So when you go for the first time on a PHP application, most of the time sessions will be handled by PHP sessions. So you will have a cookie that is named PHP sesID. So it's not readable here, but basically on your first request, you will see that the server is giving you a cookie for your session. And then this cookie is used to keep a trace of your session throughout the application. So here your token is linked to your PHP session. So if I open a new incognito window and authenticate once again as Timmy, you will see that you have another token, even if it's the same user, because tokens are linked to sessions and not to users. And then you have the post submit which happens when you click on the button, and you see that it do a nmap on the public website of the company. And so basically it says that it's open, and you have the name here. So everything is working fine. But then what's interesting is that you have a kind of a hidden parameter that you can pass to the request, which is a script parameter. So you see that there are some args, the nmap command and its arguments. And if the parameter script is set, it will add dash script equals what you send to the arguments of nmap. So the first thing here, when you see that, is that, okay, I can control arguments of a command. So maybe I can just inject a semicolon and execute like commands. But you will see here that there is some PHP native functions escape shell arg that is used. So it will take every argument of the command and sanitize it. So you can't escape the context. If you do, I guess you have a 0 there on PHP. But normally, when it's used in the proper way, it's not exploitable. So you are really contained to the script argument of nmap. And so you have to understand how can you exploit this. What script can you pass to nmap? What are nmap scripts, actually? I guess everybody have used nmap in the past. You can scan some services, and you can get some more detailed information on services. And internally, nmap have a lot of LUA scripts, which are, LUA is a programming language like Python. And so nmap will simply execute those scripts to get some information. I guess if I go on the nmap manual and I search for LUA, no, script, there should be some, yeah, you have the script part of nmap. So it's a good way to understand what can you do inside of it. So it says you can use LUA scripts. And if you explore your nmap installation, you will find a folder containing all the default scripts of nmap. But here, what's interesting is that you are able to specify your own script. So by specifying the right script, you will get able to get command execution on the server. But now, how can you specify the right script? Because nmap won't load remote scripts. It doesn't support that. So we'll have to specify a local file on the server that will be executed by nmap, and then you will get command execution. And then you can ask yourself, which local file I can take control on the server to execute this vulnerability. And so if we go back to the login page, we see that we have a file used for our own session using the token associated with our session. So basically, we sort of control the content of the log files for our own user. And so the idea here is how can you create the right content for this file to be able to pass it as an argument to the nmap command so that nmap will execute command on your behalf. So you have to understand how can you do this. Obviously, you have to use LUA because nmap expects LUA scripts. So yeah, I will leave you some time to try to craft the right log file for your own session to pass it as nmap as a LUA script to achieve a remote command execution. So that's not so easy. You don't have a lot of output when you try to debug what you're doing. But one thing you can use to help yourself is the logs.php, which basically you can send it a file parameter using a post request. And if the file is under Desgazons logs, it will output the content of the log file. So I can showcase this. If I create a new session, like this. I authenticate. I have my token, so that is useful. I can go on logout.php, and because I don't know actually if the session is really destroyed. If you go on logout, I believe you still have the PHP sys ID. Like the server is not killing your PHP sys ID, so I think you have the same token as before, but you're just not authenticated. So if you do a random authentication parameter, you get a 401. And then using another session, if you go on logs.php, we don't have any output, but we can take the request on a burp, for example. And I'm sorry because it's not really big, but basically the idea is to do a post request to logs.php and to pass the script, not the script, the file parameter, which should be in the format admin/logs dash your token, which should be in the history somewhere, I guess. I don't know if I saved. No, I don't have it in my paste. But I can take this one, I guess. And if I ask the server to output the content of this file, we don't have anything because I guess this file is empty. But if I log out, do once again random stuff, log in, and then do this again. Nope, my bad. If I take this, I'm just failing. Huh? It's supposed to work. And I know it's working. I'm just not able to do it on my side, which is a bit dummy. So I will just check what I'm doing wrong and then go back to you. Sorry for that. But basically, if you really read the logs.php, you will be able to just do a post request to get access to your log file or any log file of any log of anyone if you know the token. So you don't know tokens of other users, but you can get any token associated with your PHP session and inspect the content of the log file. And the log file will be created if you do false authentications with this PHP session. But I will just take a few minutes to make sure I can do the proper demonstration, and I will show you what it's supposed to look like. And so, yeah. peux remettre le... Parfait. Okay, so I just figured out what I was missing. It was a simple HTTP header. When I converted my request from GET to POST, I forgot to add the content type. So for the server, there was no really proper POST request. But now if we send the request, you can see here the content of your log file. I'm sorry, I cannot zoom in, but I guess I can show response in browser. Nope. Nope. Okay, so I have to change a setting inside my burp instance. Because normally you can replay your requests inside burp. It will generate a burp suite URL, like something like that. And when you go on this link using your burp that is integrated with burp suite will transform the response to give you the same output you had inside the burp. But this thing can be used by malicious websites. Like basically, when you visit a website using burp, the website can try to do some random stuff to detect if you're using burp. So I think using those type of URLs, it can expect you to be redirected. And also it can ask you to open the favicon of burp, which will you have locally on your browser. And so on a random website, by using JavaScript, the website can detect you are using burp by detecting that this type of URLs are working, and also by asking you to load the favicon of burp. So I know that some weird website on the dark web are using those type of techniques to detect if some people are trying to hack into their servers. So yeah, so that's why on my side it's deactivated inside the burp settings. So I just have to find where you can change this inside of burp to reactivate this feature, which I don't remember. The detection of a burp by deactivating this feature. So like that's why it's not working on my side when I try to replay the request, because inside burp settings you can just deactivate to do what? To do this in burp? Yes, there is a burp option to, but I just have to find it. When I will have found it, I can show you where to do it. Yes, that's right there. So basically, there is option saying disable web interface at http://burpsuite, which is also, I guess, the URL you can visit to download burp's certificate. So like when you launch a new burp and you want to register your certificate, there is the convenient way to visit http://burpsuite, and it will download for you the certificate. And so if I enable it again, normally now I can have my request that is being replayed in my browser. And so I get the output of the log file I've asked to get the content of it. So this can help you to understand how to exploit the remote command execution to understand what is going on inside your log file. And maybe you can then copy its content locally and share with a local instance of Nmap to execute locally a script with your log file to understand what's going on and maybe why it's not working. So basically, take the log file, copy it to a local file, and launch a local Nmap asking to execute the script, which is a local file. And then you will get errors from Nmap. Maybe it doesn't expect certain characters or anything. Basically, if I do it, if I take this content and I save it in a random file, and I do with Nmap dash script égale tmp/1 and asking to scan my localhost. Nmap is not happy, not at all. It says the variable random garbage stuff is not declared. That's because in LUA, this will be interpreted as a variable which doesn't exist. So it's giving an error. So yeah, try to craft the log file and try to debug locally to understand how you can have the correct log file. I will leave you some like 15 minutes to try to give you a chance to exploit it. And after that, I will also leave the instance up for a few days if you really want to just try on your side, but I will show later how to achieve this vulnerability. And then there is a final privilege escalation that we might have to go quickly through it because I don't have a lot of time left. Execution, like the different steps you have to do. So you can use that as the base to create your attack. So yeah, you just have to get the right content inside the log file using malicious authentication requests. Perfect. C'est ça. OK. Okay, so I'm going to spoil you a bit and give you the answer to how to exploit this vulnerability. So I saw there were some good tries, like I can see all the logs on the server. So here I have all the log files that were created by everyone. And so if we open a random one, we get here logs for something. And yeah, so I will use also this to show you what's happening server side while doing the request client side. So on the attacker perspective. So the workflow I gave you was to get a new PHP SES ID. So this ensure you will get a unique token, because once you have a first token and you do a bunch of stuff, you will always write inside the same file. And so at some point, your file is just useless because there will be a lot of garbage stuff. And so Nmap will just get errors for all the things you tried before. So the first thing you want is to make a clean slate and have a new file. So you just get a new PHP SES ID. And you can do this by simply doing a get request on a slash with no cookies and yeah. So basically, the server is wants to redirect us to login.php because we are not authenticated, but it also gave us a new PHP SES ID. So we can take this PHP SES ID and we can use this to pollute a log file, which should be a new log file because there is a new PHP SES ID. So we take this stuff and we can craft a malicious request. So here, I don't know if it's huge enough. I can maybe just increase a bit more. So you have 3 parameters. The first 2 are the username and password. And you see I use integers, so 1, because otherwise, if you specify stuff like admin or whatever, Nmap will just fail because LUI will interpret this as a variable and not a string. So basically, it will encounter admin variable, which does not exist. So it will just throw an error because you're using an undefined variable. So by using integer, on the LUI perspective, it will see that the username variable has the value 1 and password variable has the value 1. So there won't be any errors here because it's just normal stuff. And then you get third parameters. And why can you pass a third parameters? Because if you look at the login.php, you see that it does a for each on all the stuff you pass in the post variable. So in PHP, the post global variable contains all the parameters you send inside your request. So it just doesn't take username and password. And obviously, for them, they expect to just logs username and password. But because it's a for each, you can unexpectedly smuggle new parameters that will be registered inside the log file, which is convenient because we have some limitations on the username and the password. Like you can't have a password above 25 characters, and it's pretty hard to do a reverse shell under 25 characters. And the username can contain like letters and numbers. So again, it's pretty hard to do a reverse shell using only letters and numbers. So by smuggling a third parameters, we can just pass what we want, which is done here. So it's like the LUI code to, I will send it to the decoder. Nope, as URL. So you see it just import the OS inside LUI and execute a Python reverse shell. So yeah, so in the end, I take my new PHP SES ID, I pollute the logs with this request, And then we need to get the token associated with the log file so we can re-authenticate this time normally. So we take the same PHP safe ID and we authenticate using Timmy's credentials. And so here the server redirect us to index.php. And on index.php, we see the token associated with our PHP session. And here I will cheat because I will just cat the content associated with this token. And so we see on the server side, after the first request, we have a file that contains -- something, and -- in LUA is a single line comment, so this is ignored. Two variables that are set to the value 1, and a third variable that it's just like inline LUA to execute a command. So yeah, this command simply execute Python, the reverse shell using Python. So now you have all the elements in your hand. You have the log file, your token, and so you can just launch the payload, the exploit. So you just submit a service scan, and you specify the script which needs the token of the corrupted log file. So we take our token here, and we specify it here. And so normally, if I open my listener somewhere, I should get the reverse shell. So no, because I have a direct answer. So this is a failure once again. This is the demo effect. Do I have the right file? No, I made a mistake with the token. I don't know which one I had. There is a missing or a new 0 at the end. Yeah, so I just had another 0, but now it's the right file. And so if I launch it, you see there is no answers because the servers is stuck at launching a reverse shell, and then we can here see that we have a connect from the server. And so now we are the Nmap users on the server. So after this, you see that you're inside the server. If you go inside the home of Nmap, you get a flag, which is like the 4th flag. After that, there is a 5th flag, which is a quick pivot to the Timmy users. So I will just poll you because it's like intermediary steps. So you just SU to switch user to Timmy. And because Timmy is a smart people, it uses the same password everywhere. So you can just get the account Timmy on the server, which is very common in enterprise to have a password reuse and weak credentials. So now you have the 5th flag. And you have last file, but I won't show you the end because I don't have that much time. And since I will leave the infrastructure up, you guys can just try to the final privilege escalation. It's much easier than the remote command execution. So just by understanding what to do, you will get a good chance to solve it. And for the remote command execution, you also have a few days. I will leave the infrastructure until Sunday night so that you guys can try it. So yeah, that's pretty much wraps up the whole presentation. So yeah, the main interesting things in terms of knowledge for me today was the dangling commits. That's why I took a huge time to explain this. And then the remote command execution is also a nice, fun, small challenge to just exploit stuff. And yeah, the privilege escalation is like a small bonus, so it's not so bad that I didn't have time to present this. But yeah, I hope you had a bit of fun trying this track, and you can have more fun trying during the end of the week if you want to get the final flag. So thanks everybody.